All right, let's get started. Hi, everyone. My name is Rupa Dachere. Welcome to my talk on home automation using Arduino and Raspberry Pi. I've been a software engineer for almost 2 decades now, and I heard about the Arduino and Raspberry Pi last year, and I thought to myself, hey, it's really two really cool pieces of hardware, and I should use these to solve this particular problem that I've had for many years. So that's pretty much what my project is about, and I'm going to be trying to talk to you about that. Before I start, just a standard disclaimer. This is my first hardware project. I've never done a hardware project before. So I wanted to solve a problem that I was having, and I learned just enough to get it to work end to end. So I am by no means an expert on Arduinos or Raspberry Pis. Probably a whole bunch of people here who know a whole lot more about it than I do. But I thought this was a cool project to do, and so that's why I'm here. This is what I'm going to be talking about today. The first thing I'm going to talk about is tell you what the problem was that I'm trying to solve, what my solution is, and why I chose that solution. I do a very high-level, very brief comparison between the Raspberry Pi and the Arduino, and I'll show you all the hardware that I've used. And yay, live demo. Hopefully it's going to work. If not, I have a backup. And I will go through all my code, and if there is time, do Q&A. If there's not any time, I will be outside, and I will be also at the CodeChicks booth in the expo area, so feel free to grab me there. So this is a problem that I wanted to solve. I wanted to know who was at my front door. I wanted to know when they showed up, what time they showed up, what date they showed up, and I wanted to be notified in a reasonably quick time frame, like 1 to 2 minutes. And this stemmed from the problem I was having with contractors, gardeners, package delivery, neighbors, what have you. Everybody shows up at the front door, and I'm at work, and I don't really know who's showing up at what time. So that was what the problem was that I was trying to solve. And so here's the solution I chose. Keep in mind that there are many different kinds of solutions, so this is just the one that I happened to choose. So let's say there's a contractor that comes to my house is going to do some work for me. I chose to have a proximity sensor, ultrasonic proximity sensor, tied to the Arduino, which detects an output change signal, sends it to the Arduino. The Arduino sends the change signal to the Raspberry Pi. The Raspberry Pi then tells the webcam to take the picture. The webcam takes the picture, it sends a picture back to the Raspberry Pi. And then the Raspberry Pi uploads the picture to the web and sends me a text message on my phone. And so that's my entire project on one slide. You have no idea how hard it was to do this stupid slide. Oh, God. I am not a PowerPoint person, so So why did I choose this solution? I could have gone to Fry and gotten all these spy cam things that you can buy, but I didn't want to spend a lot of money. And almost everything I saw that was remotely close to giving me all the features I wanted was like $500 and more, and there's no way I'm spending that much money. So the first reason was it's pretty inexpensive to do this. I spent about $90 on it, and you can spend considerably less if you have some gadgets lying around. Or you get stuff for free. The second reason I wanted to do it, I really wanted to do a hardware project because I'd never done one before, and so that was the second reason. And the third is to speak at conferences like PyCon. And, so this is all the hardware that I used. And by the way, it's sitting right here. We'll get the camera to take pictures of that too. So let's see if I can move my cursor over. I don't know if you can see this, but here's the Raspberry Pi in the red box. This is the Arduino Uno R3, which is tied with jumper wires to my proximity sensor here on the tiny breadboard. This is the webcam, and this is my USB hub, which I'm using to tie everything together. So this is all the hardware. Oh, and of course my phone. Yeah. And this is what the final result looks like. I wanted to just show you, just in case the demo didn't quite work. So on my phone, I get a text message. It says, visitor at front door. And it shows up with the URL to my GitHub account where I've uploaded the photo. And then I click on, so I drop down into the SMS app, and I click on the URL. And hey, that's me at the front door. And that's a better picture of me at the front door. So I did this morning. So yeah, so that's what, that's the end result. So here's a really quick comparison of the Raspberry Pi versus the Arduino. Raspberry Pi is, it runs full-fledged Linux, full stack. Arduino, you do small programs called sketches. You can write it in C, C++. Whole bunch of libraries out there. You can do all kinds of cool things. You can buy, daughter boards to extend it, etc. On the Raspberry Pi, 700 megahertz microprocessor, 500 megs of RAM. Arduino, 16 megahertz of microcontroller and 32 kilobytes of flash. You don't hear kilobytes very often nowadays. Right? Ethernet and SD card support are there on the Raspberry Pi. You don't have either of those on the Arduino by default, but you can add. You have to buy extra hardware and add it to the Arduino. So it is extensible. On the Arduino, it supports analog I/O, which the Raspberry Pi does not. And the Arduino also has a lot of pins, so you can, and they're easy to reach. The Raspberry Pi has some pins, and at times if I have the cover on it, it's really hard to get to. And the last point that I wanted to mention is, this is something I got from a Google search actually, is apparently the Arduino is better with time-sensitive applications, kind of like this. And the Raspberry Pi has some hiccups with that. So I haven't really tested this yet, but once I get this working reliably, that's my next step, is to just shuffle it around a bit and see if it is true or not. So here's all the software that I wrote. So I wrote this Arduino sketch, which is essentially a small program, to read the output from the sensor and send it to the Raspberry Pi. On the Raspberry Pi, I have two main scripts, Python scripts. The first one's called recognizer.py, and the second one's called sendsms.py. Recognizer.py is the main heavy lifting script. So it reads the sensor output from the Arduino on a single thread. It does an object detection. It actually tells the webcam to take a photo, and I'm using FS Webcam for that. Uploads the photo to the site. I'm using GitHub. And then it calls sendsms.py to actually send a text message. And in sendsms.py, I use the Twilio APIs to actually send the URL to my text message. So all of this is about maybe 65 lines of code, maybe less, and it can be optimized a whole lot more once I have time. So yeah, it's pretty painless. This is the proximity sensor that I'm using, and its maximum range is 16 feet. This is the Arduino Uno R3. That's what I'm using here. And just a quick run through of the components that actually are relevant. This is a USB port right here. These are all the digital pins up here. Down on the bottom right is the analog pins, and to the left of it is power and ground. And this black thing here is actually the independent power supply for the Arduino. And this is my setup with the proximity sensor. So the yellow wire is the echo pin, the green wire is a trigger pin, the blue wire is ground, and the red is power. So this is all the stuff I needed to do to get my Arduino development set up, dev environment set up. So I went to arduino.cc, which is the site to go to for Arduino stuff. Downloaded the dev kit, connected it to my Mac with a USB cable. I looked at some example sketches, and you get like umpteen of them that come by default. And that was pretty much it. It was really simple, really quick. So yeah, everybody should do that. This is a Raspberry Pi. A quick run through of some of the components that make sense here. These are the USB ports. You can see my little nano dongle here, which I have a separate photograph of. Up here is the Ethernet port. Here's the HDMI port. Here's a micro USB power, SD card, and then this is component video, audio, and I believe this is the Ethernet controller. And that's all I'm going to talk about for that one. This is what I needed to do to get my Raspberry Pi dev set up. I went to the December 16th Wheezy Raspbian image, and I used my SD card to install it. I needed a few libraries to get the Twilio APIs to work. Principally, I needed to get pip and PySerial. And the other thing I needed to know is where my Arduino output was going to show up, and it shows up in dev TTY ACM0. There's the Wi-Fi dongle. It's really cool. It's like this big. It works great. It's only $8. You should get it. Yeah. And next is the demo. I don't know what the camera is showing, actually. Let me see. I guess so. Yeah, I guess so. Oh, here we go. Okay. All right, so what I'm going to do is switch, if I can get my cursor back. Here we go. So by default, the Raspberry Pi comes with username Pi, password is Raspberry. Oh, and one other thing about the setup is because I wasn't, well, I'm still not sure about the Wi-Fi here, which I need to actually get this demo done. I actually have sharing between my Mac and the Ethernet port on the Raspberry Pi, so I'm assigning it a static IP 192.168.2.2. And now I'm in on the Raspberry Pi. I've set up my SSH keys so I don't have to keep typing the password every single time. Go to PyCon 2013. And here are my two scripts, recognizer.py and sendsms.py. And I'm going to run this in interactive mode, which will actually show you the output of the sensor on here. And so what's going to happen is I'm going to ask someone, volunteer, to come up to the proximity sensor, which is right here, and come up to it and stand there so we can see a detection. And I have a volunteer. Wait. And then, oh, wait. You have to move here. I'll tell you when to walk. It's very sensitive. And then you'll see it detected something, and then it's going to trigger, take a snapshot. The webcam's right here. It's going to take a snapshot. Hopefully it can see her face. And then it's going to do an upload of the photo to GitHub, and then it's going to send SMS. So that's the goal. I'm going to start that. Wait. Okay, so right now it's just sensing something out there. 16 feet is max. If it doesn't sense anything, it just spits out zeros. So slowly, if you come up to the sensor and stand, you have to come up pretty close, actually. Aha, okay. Detected an object, 20, 15, 18, 19. All right, now you can step away, please. Okay, so take a snapshot, do the Git stuff. Oh, crap. Okay, so there's some syncing issue with GitHub. So oh, and I got my text, and you didn't hear the obnoxious sound, but that's my text. Oops, can you see? Oh, can you switch to this thing? Yay! Okay, so that's the text message. So I'm gonna like, I don't know if you can see it. Okay, I'm gonna drop down to it. Yeah, that was my test run before. I'm going to click on it. It's going to GitHub. It's probably not going to work because I haven't synced my GitHub repo with this. Crap. Okay. It does work. If you come by the CodeChicks booth later, I will fix this, because hopefully I'll have better Wi-Fi, and will sync up my GitHub repo. So anyway, that's what the demo is. All right, now back to my slides. Okay, I need to see what it says. Ah, here we go. Okay, so we're done with that. So here's my Arduino sketch code. What I wanted to point out, the key things here are there's this new ping library, which is really, really cool. It has this class called Sonar. And Sonar has a whole bunch of methods in it. And one of the methods is ping_in, which gives you the distance in inches. There's also a ping_cm, which is the default, is in centimeters. So that's something I had to change in the code to send me the distance in inches. And here's the beginning of my Raspberry Pi code. I have 6 slides of this. So the first thing is the recognizer.py heavy lifting script. I set up the base port as dev tty acm0. And then I have this infinite loop that goes and reads the data from the Arduino output. And I have this thing called max trigger distance. What the max trigger distance is, which is why I was asking Anna to come up real close, is because I've calibrated and set it up for between 0 to 30 inches. So you have to be within that distance to be detected. And if you are, then it says detected something, as you saw in the demo. And then once it detects something, I get the date and timestamp. I create the snapshot file name. The file name actually has the date and timestamp on it. And there's this thing called valid pick count, which essentially is my rather weak attempt to mitigate noise. By noise, I mean things like butterflies and moths and spiders and anything else that just feels like crawling across and just triggering. It's a very sensitive sensor, so it just triggers at anything. So what I do is I check to see if I'm getting a consistent read for 5 counts. Right now, my pick threshold is 5. So once I detect an object for 5 counts, then I say, oh, okay. This must be a valid picture, and then I'm going to, set up the file name and then use FS Webcam to actually take the snapshot. Then I do a whole bunch of Git stuff. Add it to my local repo, push it up to github.com, and then then call send SMS with the Git URL to send the text message. This took me the longest time, was Git. The rest of the stuff actually didn't take me that long, but I still don't get Git. So then in send SMS.py, I use the Twilio APIs to actually send the text message. And the key thing here is that last line, client.sms.messages.create with your phone number, and you have to do a whole bunch of setup of the API keys and the tokens and all of that, which I haven't shown here, but it's in my code that's in my GitHub repo. Yeah, and the thing about the Twilio API, it was really easy to set up, and it works every single time. And a shout out to Twilio for giving me a whole bunch of free credits so I could keep testing. Yeah, thank you. So, hardware and cost. Cost me $90. The Arduino was $22, proximity sensor 16, Raspberry Pi was 35, and Eben says he wants it down to like $20, which would be great. Webcam was free, that was from my junk pile, and the Wi-Fi dongle actually was $12, but you can get it for cheaper. I got it from the wrong place. USB hub was also free because it was from my junk pile. Breadboards, wires, etc. was $5, and so $90 total for all of this. I am not including the, if you don't get free credits from Twilio, that would be an additional cost, but they don't charge very much. It's like 1 or 2 cents or something, so that's almost negligible. Some attributions. So I bought my hardware from adafruit.com and sparkfun.com. The go-to site for Arduinos is arduino.cc, and the go-to site for Raspberry Pis is raspberrypi.org. And I could not have done this project without Akana Peck's help. She's right there. And her site is shallowsky.com/Arduino. And for this project, I didn't use any books, primarily because I didn't want to purchase any. So I went off everything that was free online, and Stack Overflow rocks. So oh yeah, so here's my contact, rupa@codechicks.org. And my source code and slides are already up on github.com/r-share/who's there. And also, I think the PyCon, there's like a site for all the PyCon slides, and I just posted all my slides there too, so you have all of this up there. And I wanted to, oh, are you gonna throw me? Okay. Wanted to just do a quick run through of some of the issues that I ran into. One of the things with the Raspberry Pi was I initially started out with a USB hub not being independently powered, and so I was like, well, it couldn't detect the Arduino or the webcam or anything else for that matter, and eventually jumping down into dmessage, I saw, oh wait, there's no power, it's too low power, and so I had to independently power the USB hub in order for any detection to happen. The standard libraries for the sensors didn't work. The pins were wrong, the baud rate was wrong, and so I had to run around and look for examples that actually worked. And so there's a link for the new ping library that I was talking about that has the class sonar. And then I had to modify the detection distance to inches instead of centimeters, and also the frequency. By default, it's 50 milliseconds, and I upped it to a second. Let's see. I think that's pretty much it. And let me just go back to demo. Okay. Yeah, that's pretty much it. I'm going to do one more thing. I'm going to show you a video of me with this project actually working, because I'm unhappy that it didn't work here. So, oh wait, hang on.
If you're watching this video, it probably means that my demo at PyCon didn't quite work. So this is my backup.
I need an audio feed.
I'm going
hang on one second.
run through my project.
They have an audio feed. We're just going to put.
We're actually kind of out of time. Well, very much out of time. So we don't have time for questions, unfortunately. So can everyone please thank Rupa for the awesome presentation.